Okay guys, Matrix, welcome back. This is mainly Matric focused now, grade 10s and 11s, you can watch a bit. And you'll notice grade 10s and 11s, if you are watching, is that the rules of exponents are so very important in this thing. The ability to work with basic exponents. Go back to your notes and go and master those exponents, okay? And fx notation as well. Now look here, again notations, fx equals, y equals, y equals. Good. Then when you differentiate, it's f prime x equals, and you keep it all the way down, the equals there, and therefores, okay. Not another equal here, but therefores. Y equals, you've reorganized him. Now we're in a position where we can go dy over dx. Okay, good. And then remember this one as well. If you have that, is to keep as equals dx 1/3 x cubed, and you then drop the dx. Okay, so that's very, very important. Okay, now also very important before you get them into the rules, you know, rule 1, 2, 3, AXN, something x something, or something x, or a number, you must get rid of any root signs, brackets, or divide lines, specifically divide lines over variables, over x's and that kind of thing. Watch the space as we do this. So we always get rid of root signs, brackets, and divides. Let's explore this a little bit. Here's an interesting one from last year. Let's have a look. It says, find the gradients at a specific x value 1 if fx is equal to this. Now, do you notice that there are brackets there? Okay. Now, you cannot just simply say the derivative of 7x is 7 and the derivative of 1 is 1. If you look at this, you can't do that. So what do we need to do? To get it into the form we want, we are going to firstly expand it. Okay, now I want to write this down. It's so important, this. If you look at now, watch what I'm doing, my notation. Fx is equal to 7x plus 1 all squared. Okay, now I'm going to multiply out. Now listen to me, because guys, if you don't, I am going to vampire you. I'm going to come and bite you. And I'm going to be dangerous. I will see this. Okay. Be warned. Okay, now come with me. Let's master this. Watch this. Therefore, fx, don't put the prime there, but it's going to be, what's this? If you square it, 49x squared. Multiply those two and double. That's 14x plus 1. If you go 49x squared plus 1 and you leave out that middle term, you will see some funny things happen to you. In the middle of the night, I will come and I will say, rah! I will come and I will haunt you. Okay. I am a vampire from Ventrix Uploaded, ready to devour students who mess up marks of the gift. Don't do it, please, please, please. Here we go. Okay. Now, look at this. Please look at this notation. Guys, you've now got this. Now we can say f prime x. Rule 1 says keep the 49, bring down the 2, and subtract 1. This is easy. Rule 2 says it's just 14, and Rule 3 says that is 0. Okay. Therefore, look at my notation. F prime, that is 98x plus 14. Okay, 49 times 2 is 98. Now you've got that. Now notice the notation. Please get this right. And then this was from last year. Now, what you now need to do is plug in the 1. Now watch this. So you say, therefore, the gradient at 1 is 98 multiplied by plus 14, which gives you, what's that? 112. Okay, that's your gradient. 98 plus 14 is that. Okay, so watch out for that, and watch out. You don't want to mess up this. Grade 10s, you need to master this. That squaring of that thing. That's from grade 10, even grade 9 days. And Matrix mess this up, and they mess it up through notation. Please, fx equals y equals dx. We mastered those things. You've got to get it right. Okay, look at another one quickly here. Now, this is also last year's paper. Let's just see what we're going to do here. Now it's giving you y equals. So now what do? We can't just go dy dx. We've got to get rid of divide lines over variables. Look at this. There's a divide line over x. This is not nice at all. So we've got to regroup it a bit. We've got to make it worthwhile. Now watch what I do. Now I'm not going to go dy dx. I go y equals. Now what we could do, there's an imaginary 1. So you could go 3 over 2 x to the minus 1. Okay, minus, this is the same as a half x squared. Okay, please look at that, 3 over 2, that's that x goes up, and it's a something x to the exponent minus something x to the exponent. Now, you can say, therefore, dy over dx. Now you can go 3 over 2, bring down the negative 1 and subtract 1 from the original, minus a half, bring down the 2, x to the 2 minus 1. Therefore, look at my notation, therefore dy dx, small letters, gives you negative 3 over 2 x to the minus 2. Those 2's give you 1, x to the 1, and if you want to make the exponent positive, you can drop it to below where the 2 is, and you have your gradient there. People, that is so important. Look at those notations and master that. Okay, stay with us on Matrix Uploaded. We're going to pursue some more complicated types of differentiation. It's really good being with you. Stay with us.